Thank you, Ed, and good afternoon. I am Bill Cerveny. I work for Arbor Networks, and I'm actually a senior software quality assurance engineer. Arbor Networks is based in Ann Arbor, Michigan, so I checked the current temperature in Ann Arbor. It's 44 degrees. We're supposed to get snow flurries tomorrow. So at lunch, I made a point of going out and soaking in the nice weather that I probably won't see again until May of next year. So it's really nice here. So what I'm going to talk about is, so Arbor Networks develops security infrastructure systems for large service providers, for enterprises, and that's in general what Arbor does. I'm sure I'm missing some things. What I've been involved with is testing IPv6 functionality. So I've been with the IPv6 community for roughly 9 years. At Arbor Networks, I've been involved with testing software, and I'm going to talk about some of the things that I discovered and learned in deploying IPv6, some of the suggestions for other people when they deploy IPv6 in products and in software. So I guess I shouldn't walk away from the microphone. The first thing, the product and service must perform at least as well as it did before the service was added. You don't want to add IPv6 and then all of a sudden discover that other features don't work properly because you implemented IPv6. It must work as well as it did before. It shouldn't be expensive to support a new product. It shouldn't create a burden on the Arbor or the vendor support team or on the customer support team. And most importantly, early adopters may use IPv6, but the product and the service must still work for everyone else. The world today, we have roughly 1% of the world today is deploying IPv6. The other 99% is using IPv4. We have a number of customers who are very interested in IPv6 technology and have encouraged us to implement IPv6. But that said, even their networks are primarily IPv4 based. IPv4 is still very important for the product. So when you deploy IPv6, or when you look at integrating IPv6 functionality into your operating system, you need to be aware that many applications don't support IPv6, even at the source code level. They have no concept of the PF_INET6 domain. You need to chase down any sort of IPv4 centricities in your third-party libraries, such as trying to squeeze a 128-bit address string into a 32-bit string. If the IPv4 support is needed, you can ask the provider of the library, or you may need to go in and just modify it yourself. You need to watch out for unusual legacy behavior in testing and deployment. Examples, a DNS name not being found because an A record isn't present, even though a quad A record, a perfectly valid quad A record, is the only record needed. So in this case, the IP address or the domain request only returns a quad A record. Some systems don't like not having a quad A record present. Another example is the mixed environment that's occurring with DNS across the IPv6 transport. That's a challenge. So in the operating system space, and here I'm talking mostly about Unix and Linux, but it also applies to Windows systems. So you now have two default routes. You have an IPv6 default route, you have an IPv4 default route. Some applications may prefer to reference the IPv6 localhost address. Others may prefer to use the IPv4 localhost address. You need to understand that. In Unix and Linux, you have the ability to delete the link local address on your interfaces. You probably don't want to do this. Strange things can and may happen. In these systems, you have you have your firewalls which support IPv4, and you have IPv4 rules written and carefully tuned. You need to do the same thing with IPv6 in your firewall rules. Some of the user interface considerations, you want to use the 2001 :DB8 documentation block. We want to avoid situations with IPv4 where we write valid routable addresses into your documentation or into your examples on your user interface. The user interface screens must now support 39 alphanumeric characters for an IPv6 address, whereas in IPv4 you had 15 characters. Don't forget the prefix length can now span 4 alphanumeric characters, not 3. You will certainly have the challenges of supporting an unknown mix of user legacy operating systems, WinXP, Vista, various flavors of Mac OS, some of which support IPv6 better than others. In a large user environment, this will be a challenge. So one of the things that I don't think gets enough exposure is when you integrate IPv6 into a product, you have an opportunity to look at how you did things initially, how you did it with IPv4, and confirm that IPv4 is doing the right thing, doing exactly what you expected. And this really helps harden a lot of your IPv4 processes and to revisit some of the core processes which may not have been looked at carefully for a number of years. It's a big benefit of integrating IPv6 into a software product. You revisit what you did with IPv4. Many production client operating systems and network devices can support IPv6 and in fact support IPv6 now. A couple years ago, I ran ping 6 against the all-node multicast address in my office. So to my knowledge, no one would admit having IPv6 configured on their network. Yet when I pinged this FF02::1 and you need to specify the interface address, as Joe Klein mentioned yesterday, I discovered roughly 2/3 of the client or desktop computers were responding. So IPv6 was alive and well in the office network. Today you may see fewer because of firewall rules, but you'll be surprised at how many computers support v6 and you really have it running in your network today. You will likely need to work around legacy network devices which don't support IPv4 or IPv6 or don't support it correctly. And one behavior that I'm kind of fighting is the case where a certain switch doesn't respond correctly to neighbor discovery, to the neighbor discovery protocol. When I first was involved with testing IPv6, no one really used IPv6 in the office. The simple way for me to implement this and to experiment with IPv6 was to manually configure IPv6 on a limited number of desktops that needed to have IPv6 functionality for testing our product. The rest of the office didn't need to worry about IPv6. This bypassed the whole issue with having dateless address auto configuration working properly, having a DHCPv6 server running, having the clients interoperate with it correctly. While some testing and development may occur in a separate IPv6 lab, it is actually pretty easy, and I would argue important, to have some functionality introduced into your core testing and development environments. As you build confidence with IPv6, it's important to test it in as many places as you possibly can. So when I first looked at implementing IPv6 or testing IPv6, my office did not have a IPv6 block, and I'm sure this is somewhat true with a number of offices. For the testing lab, I used the unique local addressing blocks, RFC 4193, and this works just fine for a testing environment, and actually, arguably, it's a good thing for a testing environment because you want to avoid having your lab traffic leak out into the global internet if you can at all. It is very easy to make addressing errors with a 128-bit addresses. So you've got 39 alphanumeric characters. I've had experiences where I'll have this whole string, I'll cut and paste it across like 5 or 6 computers, think I have everything configured, and oh, that A should be a B, or I should be flipping these 2 characters, and I have to go back and undo all of this. It's particularly frustrating with IPv6. So things you want to think about as you test IPv6 product and service functionality. You want to conduct tests to confirm interoperability between your product and user hardware. I'm thinking of not only clients, desktop software, but in our case, I'm also talking about routers, I'm talking about switches. You want to enable new functionality in development and test lab environments and watch for this unforeseen behavior or any unforeseen behavior. You want to test it in as many places as possible, even if IPv6 functionality is passive. And here's what I consider an important point. Just because the underlying operating system claims specific IPv6 functionality doesn't mean it should not be tested. So in a software environment, typically someone will write a feature for one release. 2 releases down the line, that feature may not work. So if you're implementing a product on this operating system, you need to make sure that the underlying functionality is still working properly. So it's something you need to check. It's also the case that putting your product on top of this operating system may cause unforeseen interactions that may break on the operating system level. System tools and supporting products that claim IPv6 support may have basic flaws and bugs. And I'll talk a little bit more about that later. So since correctly behaving IPv6 is generally indistinguishable, I repeat, indistinguishable from correctly behaving IPv4, when you test it, for test IPv6 functionality, you must confirm that you're really testing IPv6. You want to look at the logs, make sure that you're really working with IPv6 addresses, run Wireshark or your favorite sniffer across the interfaces, confirm that you're really passing IPv6. Only use quad A IPv6 addresses. You'll see those weirdnesses where the application doesn't respond unless there's an A address or an A record, DNS. Where it's supported, it's worthwhile to develop a test environment where IPv6 only is in the test environment. So this allows you to shake out any sort of weirdnesses that may occur, any kind of dependencies that may occur where you're looking for IPv4 addresses. This is a very valuable test. Even if you don't plan to deploy your system in a IPv6 only environment, this is a valuable thing to test. Operating system tool documentation for IPv6 can be sparse. In some cases, it can be non-existent. So it's one thing to implement the functionality in the software. Some cases, especially in the open source community, they don't update the man pages, they don't update the documentation, and things are different. Your configuration is not as obvious with v4 as it is with v6. An example, SNMP walk. So SNMP walk with IPv4, you just specify the address. Well, if you want to use an IPv6 address with SNMP walk, you need to put the address in brackets, and you need to prefix it with UDP6 or TCP6. Trying to find the documentation to confirm that can sometimes be challenging. It's frustrating. Cryptic error messages in the open source world or with products in general also don't help with the migration of products and services to IPv6. Here, searching, doing a Google search for your favorite tool will help. The route command, which has been around forever, in my opinion, is notorious for not having very cryptic error messages. In the Unix world, Unix Linux world, the IP command is much more helpful. Don't expect operating systems and tools to support the same level of capabilities for IPv6 functionality as for IPv4. Did I say that right? IPv6 functionality as for IPv4. There is obviously a dramatic difference in demand. Importantly, fundamental bugs will be found years, and I mean years after IPv6 functionality is widely deployed. I mean, we're still discovering IPv4 bugs. It's certainly the case that there will be IPv6 bugs long after we've reached a penetration of IPv6 in the world internet community. And that's all I have. Are there any questions? Great. Thank you.